Hi students, this is Mr. Gun. So I believe that all of you have already downloaded this worksheet here before we start to this session, right? Yeah, just to give you some introduction, I'm Mr. Gun. I'm actually one of the H2 math tutor in Singapore. We are going to try something new because we are actually trying to record as many questions as in try to build up our online resources, okay? And generally what we are trying to do now is to, give free lessons every week, and we're just going to see how's the response like. So we'll be very, very thankful if you are able to, share, share the stream, and also to like the Facebook page. It will help us a lot. For those of you who just got in, if you're not sure what is going on now, you could actually just go to the website and download this worksheet here. I will see how many questions I can go through. Yeah, there are 7 questions here. So we'll see how, we can do these questions. This topic here is actually the very first topic in Sec 1. So for those international audience, if you're not sure what is Sec 1 in Singapore, is essentially the age 13, the first year of secondary school or high school in the States, secondary school for most Commonwealth countries. Yeah, and it's the topic on prime factorization. I just picked this because I know that usually this is something which students will struggle with, especially for the questions below, I think. All right, so let's just see how we can do the first one. Let's just not. So I will spend some time answering some of your questions and comments on Facebook if you have any questions. Okay, let's look at the first one first. The first one, which is express 270 as a product of prime factorization. So let's understand what's the concept of prime factorization. Okay, let me just bring out the question. I need to find the questions on my pile of worksheet. This is okay. Hold on. Give me some time. Okay, great. So this is it. Okay. Okay, let's look at this question here. You're told to express 270 as a product of its prime factors. So just like atoms is in chemistry, right? So for every compound you have, you break it into its the most fundamental form, which is atoms, right? So for numbers, the most fundamental form is actually prime factor. So the reason why we want to break it apart from prime factor is actually pretty simple. We want to see how the number works. All right. So if you're able to break numbers down into its purest form, which is the prime factorized form, then you can do quite a few things with it. So later on we will see how we can do that. So the first thing is to just list down the prime numbers. We know that 1 obviously is not a prime number. So we have 2, 3, 5, 7, and so on. That's about it. So bringing our calculator is actually quite fast. So you just take 27. This is an even number, right? So what we're going to do is actually just put 270. Okay, this is like working. You don't really need to write this working in the exam because usually it's just 1 mark. But for the Sec 1s, usually the teachers would ask you to write down. So 135. So what 270 divided by 2 will be 135. And 135, so you move down from the prime factors, you move in ascending order. You started with 2, so you just cancel this out. And you move up to the subsequent, which is 3. So you just ask yourself whether 135 could be divided by 3. Just put it down. It could. So this is 45. And I believe this could be divided by 3 also. So you just put the divided by 3 here. And this will be 15. Then still could be divided by 5. And 5. And ultimately you get 1. Right? So 270 is actually 2 times 3 to the power of 1, 2, 3 times 5. Okay, so but don't forget to check your answer in the exam. So just quickly key in calculator and see whether your prime factorized form is correct just by keying in like that. I think there's nothing like, yeah, that's just like that. All right, so this is how we do this question here proficiently. Okay, so let's look at the subsequent one. For those of you who just joined us, please do look at, download the worksheet from the link in the description. I'm not sure where is it. yeah, you'll find it somewhere attached to it. Let's look at the subsequent part, which is actually putting 1500 as a prime factorized form. Okay, good. Let's look at that now. Let me try and save this form first. Okay, let's look at this. Alright, so let's look at this question here, which is asking you to, express 1500 as the product of its prime factors. So let's see how we can do this proficiently. Same thing, prime factors, just like what we did just now, which is you just list down all the prime numbers out. So 1 is not a prime number. By definition, prime number starts with actually 2. 2 is actually the only even number. So 2, 5, and then 2, 5, 2, 3, 6, 7. Okay. 11? I think. Okay, so anyway, you just move on by putting 1500 and just start dividing with 2 first. Okay, so divide by 2. And if it's an even number, just continue with your exciting life, which is just divide by 2 again. And this is obviously not an even number, so don't divide by 2, stop. Okay, so means there's no other, just stop 2 and move on to 3. Oh, okay, 3. So then after which, so we could write down the intermediate step like that. So I'm just going to write it down like 1500 divided by 2, which is 750. And this case here, divided by 2 again. Divide 2 again with 375. Am I right? Okay, great. Then after which you move to the next prime number, which is 3. Then you just move on to 3, which is 125, and 3, 125. Like I say, this is just like working. Usually in Sec 1, teachers would, okay, so yeah, if you divide with 3 again, and this is a fraction, obviously it's not divisible by 3, so you stop and move on to the 5. So move on to 5, it will be 25, okay? So this is pretty okay. Then you're just gonna do like usual stuff, which is 5, 5, and 5, 1. Okay, great. So this will be 1500, which is 1500, will be 2 to the power 2 squared times 3 times 5 cubed. Okay, so don't forget to also just use your calculator, times 3 times 5 to the power of 3. This will be 1500. So this is how we do this question here proficiently. Yeah, I think it's a pretty okay question. Okay, so let's look at the subsequent one. I hope you all have no questions so far. I am going to do the subsequent one, which is to see how we apply, okay, the questions in prime factorization. Okay, I need to find the question. You just hold on first. This is I don't know what's the question number. Okay, I got it. Great. Do you have any questions? I hope you all have no questions. Let me look at the question the comment section and see. Okay. Alright. That's really okay. I think it's not that bad. Okay, great. So let's look at hi Yvonne Yen. I just saw your message. Okay, sorry, I just want to go through the simple ones, then we can just see how we can do the more bit more funny ones. Okay, let's look at this question here. Alright, so let's look at this question here, which is on finding application of prime factorization. So for A, you're told to express 5832 as a product of its prime factors. I think that's pretty okay. So you could just use your calculator. So let me just explain prime factorization in index notation. So just leave it in index notation, which was what we did just now. List out all the prime factors 2, 3, 5, 7. Prime factors meaning the prime numbers. So here you just put 5832 divided by 2, and this is still an even number. So just keep dividing until you get 1, right? Or rather, you keep dividing until you don't get an even number. And 729 is no longer even, so we're just going to move on to 3. So 3 here, this will be 2, 4, 3. Then we divide again. That is again, and again, and again, and again. Okay, so this is like that. So what you're going to do next is actually just count the number of 2s and number of 3s that you divided with. It's not too bad, but we have to scroll. So this is 3 2s. So 5832 is actually 2 to the power 3, because we have 2 times 2 times 2. There are 3 2s there. After which we have 1, 3, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4, 5, 6. So this is 3 to the power 6. Okay. What you need to do is obviously just put in calculator and check whether your answer is correct. You just check. Okay, there's no harm. So this is correct. So this is how you prime factorize 5832. All right. Let's look at part B. Now, without using calculator, you are told to actually find the cubic root of 5832. Now is that when we use prime factorization, is basically we break the number into its composite form, or in other words, we break it into its most basic form, and we want to understand how the number works. Okay, you break it to its the simplest prime factorized form. You can actually see how the numbers what is made out of, right? The number is made out of. So this case here, we have a 5832. What we're going to do is actually we want to find the cubic root, which is a third, right? In this case here, this will be 2, 3 times 3, 6, 1/3. So there are many ways to do this. One is to ask yourself how many, like, because this is a perfect cube, presumably, then you just want to find a cube, like here. Or you could just divide the power with a third. So divided by take the 3 divide by, that will be the fastest way actually. So I prefer that actually, because it's easier. So let me explain a bit. Here it will just be 2, 3 divided by 3 for the power. Or you could just put 3 divided by 3 times 3, 6 divided by 3. So this will be 2, 1 times 3, 2. This will be 9 times 2, 18. Okay, so that's how, hence, you need to use the index notation form. So similarly, don't forget to just, check your answer by cubic and see, yeah, it's 18. So that's how we do this question here proficiently. Yeah, any question or comments, please do let me know. Yeah. All right, I think this question is pretty okay. We should move on to the next one. Let's see. So we have done 1, 2. We need to do, we have done 3. Okay, so 4, 5, they are actually the same. So that's pretty okay. We could do 6 and 7. I'll just go through 4 quickly. So that, yeah, that is U2, L2, P1. U2, L2, P1. Any questions or comments? Let me see. All right. And we're live, right? Sorry. I'm very new to this. This is my first time live streaming. So I have to check once in a while. Oh, sorry. It keeps. Okay. Yeah, we're still live. Okay, great. Any comments? No. Okay, good. Okay, let's look at the subsequent one, which we are going to do question 4. Question 4 is also from the same set. Let me just flip it up. Hold on. This would be from question 4, 74, L2P1. Question 4. Yeah, okay, great. Got it. Okay, let's look at this question here, which is how do we apply and use prime factorized form. So for the first one, I think it's pretty okay. We have done it many times. So the first thing is to just list out the prime factors. So this would be 2, 3, 5, 7, and so on. Just list it down. These are the prime numbers, the first few prime numbers. Once we're done with that, we're gonna just continue 74088 and just bring out 74088 and divide it by 2. And it's still even number, so divide by 2 again. And just keep dividing by 2 until you don't. Okay, so this is not even number, so you could just safely cross out 2. Then after which you move on to the next prime number, which is 3. Divide 3 and divided by 3 again. Just keep dividing by 3 until you get a fraction. Okay. I don't think this could be yeah. So there you go. So once done, cancel it out. Obviously, this could not be divided by 5. So if we look at this, this could not be divided by 5, right? So we just divide by 7. It's 49. I think divided by 7 divided by 7. So this is 1. So you just keep moving it down until you get 1 at the end, right? So this case here, what we're gonna get is just go back and count how many 2s I have. 1, 2, 3, 3, 2. So this is 2 to the power 3. Okay, 2 times 2 times 2 is 2 to the power 3. After which we're gonna get, we're gonna count our 3s. So just look at calculator. This is 1, 2, 3, 3. 3 to the power 3. So this is multiplied with 3 to the power 3. And 7. 7 to the power 3 multiplied by 7 to the power 3. Okay, so this is how you find the question, how do you do this question here properly. Whereas for part B, you are told to find hence or otherwise how to find the cube root of 74088. Okay, so similarly, what you need is cubic root of 74088, right? And what you need to do is just put in 3, 7, 4, sorry, just copy what you did previously, which is 2 cube times 3 cube times 7 cube. Okay, so this is cubic root of 74088, meaning we broken it down to its prime factorized form. And what we can do now is just divide, because the cubic root of 3 meaning to say that you divide its power by 3. So this will be 2. 3 divided by 3 will be 1. Okay, so this is 1. 3 divided by 3 will be 1 as well. So it's 3, 1, 1 times 7, 1. Okay, so this will give us 7 times 21. This is 42. Alright, same thing. Please key in calculator and check your answer before you proceed to the next question. Okay, so for students who are, so we've done this. Okay, let's look at question 5, which is an interesting one. Let me go and dig out the question. I need to find where is the question located. It's not easy to find. This is under L3. This would be 4500. Okay. Okay, great. This is the one. We just few more. Okay, this question here. Let's see. Hold on. Okay. So let's look at this question here. So let's look at this question here, which is on how to prime factorize and how do you actually apply prime factorized form. We are looking at A. So 4500 seems familiar though. Did we do that just now? Okay, anyway, we can just do this again. 4500A. Okay, this is why you prime factorize. For part B, you understand. We'll see how we apply it, okay? So then you understand why we prime factorize it. So 4500 in a product of its prime factors, similarly, just list down all the prime factors 2, 3, 5, 7, 11, and so on. Just list it as such, and afterwards just start dividing. So 4500 divided by 2, and this is 2250 divided by 2 again. Then you know that this is no longer an even number, so just stop. Then you can just cross out 2. And after which we're going to do is we're going to divide by 3. The 375 divide by 3 again. 125 and divide by 3 again. So this once is a fraction, just stop. So we could try and see. Divided by 5, obviously, this, because it ends with 5. And divided by 5 and 5 again. So there you go. So 2, you have 2 2's there. So this will be 2 square. Then 3 squares times 3 squares times we have 5 3's, right? So 5 3's, so 5 to the power 3. So this is how you do this part here proficiently. After which you have part B, which is given that 450k is a perfect cube. So this is the interesting bit. Alright, so 450k is a perfect cube. Okay, now you're told to find the smallest possible value of k. So what is a perfect cube? We ask ourselves, what is a perfect cube? So it could be 2 cubed, or say 3 to the power 6, or say 7 to the power 3, or say 7 to the power 12. Anything which is the power which is divisible by 3, that will be a cube, right? So essentially, if you have say that this over here, because 7 to the power 12, if you were to put cube, which is like that, 7 to the power 12, it will be cube rootable, if that makes sense. It will be a perfect cube because this is a multiple of 3. Okay, so just remember that you have to be a multiple of 3 in order for you to be a perfect cube. Okay, so let's see how we could understand this. So 4,500k is 2 squared times 3 squared times 5 to the power 3k. Okay, in other words, this k can be any value. All right, it could be 2 6 times 3 3 times 5 3. It could be 2 6 times 3 6 times 5 6. It doesn't matter. Okay, it could be any other combination. But the thing now is because what is the one which narrow it down to and eliminate it to one possible value, okay, is this thing called smallest possible value. You want this number to be multiplied so that it will be a perfect cube, and k has to be the smallest. All right, it cannot be any number, any other number. So what we need to do is actually figure out what would be the smallest number. So if this is 2 square, the smallest multiple of 3 nearing 2 will be 2 cube. Okay, we need to bump it up because k is a positive integer. Okay. Smallest possible value of k. Write down smallest possible value of k. K has to be, I think k has to be a positive integer. Sorry. So this is smallest possible positive. It has to be it has to be a positive integer. Okay. So in other words, you need to bump up. So this case here will be 2 cube times 3 cube times 5 cube. Okay. So what is missing is essentially 3 here. This is 2. So this is actually multiplied with 2. What is missing? And after which you have 3 cube here, so multiply with 3. So k is equals to 2 times 3. So this is 6. Smallest positive integer k. Okay, it has to be a positive integer because or not, k could be a fraction. Yeah. So this is how I do this question here proficiently. Any question, please do let us know, and I'll see you in the next question. Okay, let's look at the subsequent one. I have to look at the subsequent, which is we have already done this. Let's look at 6 and 7. That will be our last 2 questions of the day. 720. This would be L3 U2 L3 P1. Okay, let me check. L3 P1 question 9. Question 21. It's a long way ahead. Oh. L3 U2 L3 P1. Question 21. Okay, great, got it. Let's look at that. So we are looking at this question here. This question here, question 6. Okay. Yeah. Let's see, question 6. So question 6. Let's see. Hi students, let's look at this question here, which is on the application of prime factorization. So I think for the first part is pretty okay. The first part, express 730 as a product of its prime factors. Same thing, what we're going to do is actually just put this as 2, 3, 5, 7, 11, and so on, right? 720. So we just start off with 720 divided by 2. And divided by 2 again. So I'm just going to divide by 2 until I don't get an even number. Alright, so this will be 45. 45 is not an even number. So 45 likely could be divided by 3, then another 3, and another 5. Okay, so this will be 1, 2, 3, 4. So 720, you have 2 to the power 4 times, we have 2 twos, right? So 3 square. So this is 3 square times 5. Great. So I think this is pretty okay. Not really an issue. Let's look at B part 1. Hence write down the largest integer value such that, which is a factor for both 3,500 and 720. Okay, this is what we call highest common factor. We will briefly go through this now, but next week we will look at how we could do this more in depth. So let's look at how we can try this. So largest integer, which is a factor for both. Okay, so 720 would be 24 times 3 square times 5. So times 5. Okay, usually what I will tell my students to do, this is what greatest common divisor. So some countries say it's greatest common divisor, and some is HCF and whatnot. But essentially it means the same thing, meaning to say what is the greatest number which can divide both of these number here. I'm going to align the values properly. So 2 to the power 2 square with 2 to the power 4 here, and this will be 5 cubed times 7. All right. So HCF, just imagine if 3,500 and 720, if the first guy has got 2 square and the second guy has 2 to the power 4. Okay, just imagine that you have two $2 notes and I've got four $4 notes, and we walk into the restaurant and we decide to both buy the same meal. Okay, but what is the maximum number of the highest value meal that we could buy? So if you have two $2 notes and I've got 4, was it that if you have two $2 note and I've got four $4 note, obviously we are going to go with your two $2 note, because that would be the highest common meal that we can buy from the restaurant. So this would be 2 square, right? Now then, after which you move on to the next one, which is 3 square here. So if you think about this 3 square, I have two $3 and you do not have. So essentially, I'm not going to spend my $3. Then we move on to the 5. So you have 3 $5 notes and I've got 1. So you're going to stick with me because we are going to just use the $5. So that's how you think about it, right? So the highest common factor, you take the lowest. Yeah, because it has to be common. So this will be 4 times 5, which is actually 20. So B part 1 will be 20. Let's look at part 2. So you're told to find the smallest positive integer k for which 720k is a multiple of 3500. Okay, this is interesting. So we try and understand what's going on here. So 720, we got 2 to the power of 4 times 3 square times 5k is a multiple of 3500. So 3500 will be 2 square times 5 cube times 7. All right. So that's how we're gonna do that. Okay. A multiple of this. Okay, great. Now if this is too difficult a task to understand, what we could do is actually we make use of a smaller number, for example 12 and 4. All right, so we know that 12 is a multiple of 4, but how so? Why is 12 a multiple of 4? So like I say, prime factorization is to break the number now to its most in its sort of like its brick form, right? So 12 is actually 2 square times 3. 4 is actually 2 square. So in order for 12 to be a multiple of 4, you realize that actually 12 contains 4 in its prime factorized form. That's the idea there, right? So in other words, if you want 720k to be a multiple of 3500, meaning to say 720k, it must contain 2 square, 5 cube, and 7. Okay, so that's minimally it has to contain that. So minimally it has to contain. So that's why the question is asking for the smallest positive integer k. We go to each prime factor and just slowly see what is lacking for 720k. Okay, so 2 to the power of 4 actually contains 2 square. So this is settled, right? We know that 2 to the power of 4 could divide by 2 square because it contains it, so it's fine. After which we move on to 2 cube, 2 square. We know that it doesn't matter whether it has it here or not. So it doesn't really, it's okay now, because now you can just put a 1 here. 3 square could be divided by 1, so it's fine. Okay, let's move on to 5 on this hand here. So 5, if you put the 5 and the 5 cube here, you know that you could not be divided nicely. So what is lacking here is actually to 5 cube. So minimally, this has to change to 5 cube if it's possible. All right, and obviously that it doesn't contain a 7 here, so we need to multiply with a 7 as well. So 720k, minimum 720k with 4 times 3 square times 5 cube times 7. All right, so that is the main thing. So once you're done with this, then you just compare. What would be is 5 square k has to be Okay, this from here 720 to 5 cube times 7, k has to be 5 square and times 7. So this is 5 square times 7 over here. So 5 square times 7 would be 25 times 7, which is 175. I hope that makes sense. Yeah, so this is how we do this question here proficiently. Any question or comments, please do let us know, and I'll see you in the next question. Okay, let's look at the last question of the day, and we could just call it a day, a night. Yeah, question 7. We're gonna see this. Question 7. Question 7 is let me go and find it out. It's okay. Okay, great. I think it's not too bad. This question here is not too bad at all. So we're gonna write it down. Okay, great. There you go. Alright, students, let's look at this question here, which is on prime factorized form. So you're given that 3780 could be expressed in its product of its prime factor. So as you could see, these are all prime factorized. So they are asked, you're told to actually write down the value a and of b. I think that is pretty okay. Actually, you just need to write it down. So you could just divide it as, you see, this is 2 square, and this is 3a. So we're just going to take 3780 divide by 2 square. Divide by 2 square first, right? Then you move on to 3. So I'm just going to keep dividing by 3. Divide 3 again until I get a fraction. Until I think, yeah, you can't divide by 3 here because 35 is not. So this will be divided by 5 again and divide by 7. Okay, so when you prime factorize it, 3780, this will just be 2 square times 3. We have 3, so this is 3 cubed times 5 times 7 times 7, 1. Alright, so in other words, what we're going to get is essentially a equals to 3. So we compare, just compare only. So this is a is 3, and b is 1. That's about it. It's quite an okay question. 3 equals to a equals to 3. B equals to 1. Great. So that's how we do this question here proficiently. Okay. Let's look at the subsequent part. So subsequent part, we will find the smallest value of k when 3780k is perfect square. So we want it to be perfect square. So it's similar to the question just now we did. We need it to be oh, it's not really, okay, so it's not really. So but 3780k, this will be 2 square times 3 cube times 5 times 7, right? K. So you want it to be a perfect square. Perfect square meaning you want the same thing. This question this question is asking for smallest positive integer. It has to be smallest positive integer. K, smallest positive integer k, okay? Because it has to be integer. If not, it won't work. So I'm sorry, I never vet through these questions here. So the question now is you're told to find it so that you become a perfect square. So perfect square will mean that actually this will be you need to k meaning if it's a positive integer, meaning you're bumping up the power. So 2 square is already a perfect square, so we are fine with it, right? But what is lacking is actually 3 cube is not perfect square, so we need to bump it to 3 to the power 4. So in other words, this k here we need to multiply with a 3, right? Multiply with a 3 so that this would be a 4. That's lacking. Now same with 5. 5 is just 1, so minimally to bump it up, it has to be 5 square. All right. So this I'm just going to add to the list of k, which is multiply with another 5 here. Then after which 7, similarly, this is just 1, and because I need it to be the perfect square, this will be multiply with 7 square. So this would need to be multiplied with another 7. All right. So this k here, minimally k has to be k equals to 3 times 5 times 7, which is 105. So this is how we do this question here proficiently. Any question or comments, please do let us know. Keep practicing, and I'll see you in the next question next week. Okay, people, I've received some questions of how to do. Okay, some people are asking us some question, right? Okay, I was just gonna answer your question. Like I say, we will really appreciate you if you are able to like our web page, because it will really help us in terms of you get the updates and stuff like that, right? But generally, okay, let me check the comments. So some of you are actually asking me to go through 6b, is it? So I'm going to go through 6b with you. 6b, let me explain again. Or multiple. Part where multiple 5 square and 7. Let me explain that part. I need to find the question. It's question 21. So I have a lot of questions here, that's why I need to be able to find them out. Okay, let's see how we can do that. Can you explain multiply 5 square? Okay, great. I think I'll just go through this again, alright? Then just to clear up some of any other questions that you want me to go through, just let me know. Maybe I just erase it. Okay, let's just erase it. Okay, let's try and just understand part 2. Let's look at B part 2. So the smallest positive integer k for 720k to be a multiple of 3500. Now there's another way to do this if you want to. So if you want it to be a multiple, okay, maybe this is too difficult. Like maybe I didn't position myself properly. So you want this to be perfect. Could be divided, be perfectly divisible by 720k, right? No, the other way around. 720k divided by 3500. You need it to be perfect, right? So if it's multiple of it, it has to be an integer. So this, when you divide, it has to be an integer. Okay, I think this will probably be easier. So 720 would actually be 2 to the power 4 times 3 squared times 5 times k, and 3500 would be 2 squared times 5 cubed times 7. Ta-da! Okay, so this will be easier because I think at a glance you will be able to see how things are working now. You know that 2 square could actually be divided here, so this is no kick at all, because this is actually a perfect it could be divided properly. Now then after that, when you divide this would be, when you put the 1, this will be 2, right? Because you take out 1, this will be 5 square, and what is left here is actually 2 squared times 3 squared times 7 over 5 squared times 7. I hope I'm doing this correctly. Hold on. Yes, okay. Okay, you get it? Now, what is left below here is whatever the top of whatever 720 could not cancel. So that's the reason why, in order for this to be a perfect divisor of a multiple of 3500, this k has to be minimally 5 squared times 7, so that this could cancel with this. You get what I'm saying? Yeah. Sorry, I should have just stick to this method initially. But anyway, it's okay. I guess if you don't understand the first method, you can always stick to this. So hence, k will be 5 squared times 7. This will be 175. Okay, so this is how we do this question proficiently. Any questions, please do let us know. Keep practicing, and I'll see you in the next question. So generally, we will try and stream every week. We will try and collate and see how the response is. Like as I said, today is our first day of streaming. We will have to compile weekly worksheets as well. So please go to the website and just download the worksheet every week. Subscribe to the newsletter and subscribe to liking the page, and by liking our YouTube account, subscribe to our YouTube account, so that whenever we go live, you could ask us question and go through with us. So I hope this lesson have been beneficial. Yeah. Sorry for any of the cock-ups that we have, because it's our first day doing it. So I thank you for your patience and also your understanding. Yeah. So if you have any other questions, let me check. Okay, great. I think that's about it. So yeah. Next week we will stream a bit later because I realized that I have something to do until so we will start our streaming at 9 o'clock, 9:30 actually. So but subsequently we will do at Friday 8. Alright, Singapore Malaysian time. Okay. So yeah. If you have no questions, I guess I will call it a night. Bye guys. Have fun.